Welcome to the Connecting with Remote Serial Equipment via Cellular video. In part 1 of this video, I'll present a solution for serial M2M systems by describing the target equipment, the USR 3510 cellular gateway, the serial interface between the target equipment and the cellular gateway, the local application server or terminal, the cellular network, and the gateway's serial port to TCP feature that bridges the serial port to the cellular connection. Then I'll diagram two types of mobile-terminated system. In part 2 of this video, I'll demonstrate how to set up a serial connection using typical equipment and suitable cellular services. I'll choose a suitable cable for connecting the gateway to the target equipment and then demonstrate how to enable and configure the gateway's serial to cellular bridge and how to verify cellular connectivity. And finally, I'll test the end-to-end connectivity to the target equipment. Now, part 1, the solution. An M2M data communication system that has remote equipment initiating a cellular connection to a centrally located host is making a mobile-originated cellular connection. The host may be a manually operated terminal or an automated system that has an application running on a server. An M2M data communication system that has a centrally located host initiating a cellular connection to the remote equipment is making a mobile-terminated cellular connection. The host may be a manually operated terminal or an automated system that has an application running on a server. The remote target equipment has a serial interface that may be either a DTE or a DCE. All serial interfaces are classified as either DTE, data terminal equipment, or as a DCE, data communications equipment. Serial interfaces also have operating parameters. These are baud rate, also called speed, the number of data bits in a character, the number of stop bits in a frame, the type of parity bit, and the type of flow control. And the target equipment may or may not include a command line user interface. Also at the remote location is a USR 3510 cellular gateway. The gateway has an Ethernet port that provides a graphical user interface for configuring the gateway's operation. The user interface is accessed by directing a web browser to the gateway's IP address. And the Ethernet interface also provides a DHCP server for easy connection to a computer. The gateway also has a cellular radio to connect to cellular data networks. The gateway must be provisioned with either a dynamic IP address to make mobile-originated cellular connections, or with a static IP address to receive mobile-terminated cellular connections. And the gateway has a serial port that is a DCE presented on a DB9 female connector. And the gateway must be configured to bridge its serial interface to its cellular interface. The cellular gateway will interface to the target equipment over a serial connection. To make a connection between two serial devices, the type of RS-232 signals at each end, the type of connector at each end, and the serial parameters at each end must all be considered. There are many types of serial cables and adapters. The correct cabling depends on the type of RS-232 signals each device has and the type of connector presented by each device. Now I'll illustrate several examples of serial cabling. The serial port of the USR 3510 cellular gateway is a DCE presented on a DB9 female connector, which is the most common type of connector for a DCE serial interface. The target equipment may be a DTE presented on a DB9 male connector, which is the most common type of connector for a DTE serial interface. In this case, the correct cabling is a standard DB9 male-to-female serial cable. The The target equipment may be a DTE presented on a DB25 male connector, which was, for many years, the most common type of connector for a DTE serial interface. In this case, the correct cabling uses a DB9 male to DB25 female adapter, along with a standard DB9 male to female serial cable, or use a pre-built DB9 male to DB25 female serial cable that's wired the same as the DB9 to DB25 adapter. The target equipment may be a DCE, presented on a DB9 female connector. In this case, the correct cabling uses a DB9 male-to-male null modem adapter, along with a standard DB9 male-to-female serial cable, or use a pre-built DB9 male-to-male serial cable that's wired the same as the null modem adapter. In rare cases, the target equipment may be a DTE presented on a DB9 female connector. In this case, the correct cabling uses a DB9 male-to-male gender changer, along with a standard DB9 male-to-female serial cable, or use a pre-built DB9 male-to-male serial cable that's wired the same as the gender changer. The target equipment may be IT networking equipment, and IT networking equipment often has a console port that's presented on a RJ45 connector that may be wired as a DTE or as a DCE. When an RJ45 console port is wired as a DTE, the recommended cabling is a standard Ethernet cable and a widely available DB9 female to RJ45 adapter, and a DB9 male-to-male gender changer. When an RJ45 console port is wired as a DCE, use an RJ45 rollover cable instead of the Ethernet cable. The familiar and widely available blue console cable can substitute for the rollover cable and the RJ45 adapter when the console port is wired as a DCE. Some target equipment may use other non-standard connectors and wiring. Contact USR if you need help choosing the correct serial cabling. Besides the cabling requirements, all serial interfaces also have operating parameters. And for the serial connection to work, the operating parameters of both devices must match. Normally, the serial parameters of the target equipment are fixed, and the serial parameters of the gateway must be configured to match the target equipments. At a local operations center is a host that wants to connect with the remote serial equipment. When the host is a server, it is connected to the internet and is running application software that handles the data communications. When the host is a manually operated terminal, it is connected to the internet and is running application software, or is running terminal emulation software such as PuTTY, TerraTerm, RealTerm, or others. More elaborate M2M systems may actually host the application on a cloud server. This arrangement is beyond the scope of this video. The details of the cellular network that connects the local host with the remote sites depends on whether the connections will be mobile-originated or mobile-terminated. For a mobile-originated system, the remote sites initiate connections to the local host. The local host may be a manually operated terminal, or it may be an application running on a server. The local host first connects to a local area network, which gives it access to the internet. The local area network will undoubtedly have a firewall to protect it from threats on the internet. For a mobile-originated system, the local host must have a static IP address on the local network. The gateway will be connected to a cellular network, which gives it access to the internet. The cellular network may or may not have a firewall to protect it from threats on the internet. For a mobile-originated system, the gateway will normally be provisioned with a dynamic IP address on the cellular network. This type of provisioning is very common and is available from any cellular service provider. When the gateway tries to initiate a connection to the IP address of the local host, the LAN firewall blocks the connection. So a VPN tunnel must be configured from the gateway to the LAN. For the safety of your network and servers, USR does not recommend using other, less secure methods for allowing connections into the LAN. Once the VPN is set up, connectivity to the local area network can be tested by sending a ping command to a server on the LAN. With a terminal connected to the cellular gateway, the operator enters a ping command at a command prompt using the IP address of a server on the LAN. The ping should return to the terminal if the cellular network, the VPN, and the gateway are properly set up. For a mobile-terminated system, the local host initiates connections to the remote sites. The local host may be an application running on a server, or it may be a manually operated terminal. The local host first connects to a local area network, which gives it access to the Internet. The local area network will undoubtedly have a firewall to protect it from threats on the Internet. For a mobile-terminated system, the local host normally has a dynamic IP address on the local network. The cellular gateway will be connected to a private cellular network, which gives it access to the Internet, and the private cellular network will also have a firewall to protect it from threats on the Internet. For a mobile-terminated system, the gateway must be provisioned with a static IP address on the private cellular network. When the local host tries to initiate a connection to the IP address of the cellular gateway, the cellular network's firewall blocks the connection. So a VPN tunnel must be configured from the local host to the private cellular network. The private cellular network, the VPN tunnel, and the static IP address are typically not available from a consumer-grade cellular data plan. Contact USR for help finding a suitable M2M cellular service provider. Once the cellular services are set up, connectivity to the cellular gateway can be tested with a ping command. Note that ping cannot test connectivity all the way to the target equipment. For the cellular gateway to respond to ping, it must have ICMP enabled. Note that ICMP is disabled by default. The operator enters a ping command at a command prompt using the IP address that was provisioned for the gateway. The ping should return to the terminal if the cellular network, the VPN, and the gateway are properly set up. To pass serial data between the local host and the target equipment, use the gateway's serial port to TCP feature. Here's how it works. To receive a mobile-terminated connection and pass serial data between the local host and the target equipment, enable the serial port to TCP feature and set the TCP server setting to local. Enter the port number that the host will contact and configure the serial parameters to match the target equipments. To make a mobile-originated connection and pass serial data between the local host and the target equipment, enable the serial port to TCP feature and set the TCP server setting to remote. Enter the IP address of the host, enter the port number that the host requires, and configure the serial parameters to match the target equipments. There are two approaches to building a mobile-terminated system that has two or more target units. One way is for each target unit to have its own cellular gateway. Each gateway is identified with a unique IP address, and all target units can be identified by one common destination port number. And each gateway has a serial connection to a target unit. With the other approach, the target units share a single cellular gateway by using a console port server, such as the USR 4204. The gateway is identified with a single IP address and port number. The gateway has a serial connection to the console port server, and the console port server has a serial connection to each target unit. Then the console port server allows the operator to select any target unit. The benefit of this approach is the lower monthly cost of just one cellular data plan. That's how a serial M2M system over cellular works. Now, part 2, a demonstration of a mobile terminated connection. Note that the configurations shown in the following demonstration are based on my target equipment, my cellular services, and my networking preferences. Each M2M application is unique, so these configurations will not apply in every application. Contact USR for guidance in configuring your M2M application. For a prototype system, the terminal, the gateway, and the target equipment should all be accessible at the test location. In this example, the terminal is a Windows 7 laptop computer. This computer has one Ethernet port that will be used for a connection to the Internet and for configuring the gateway. The web browser on this laptop is Chrome, and the terminal emulation software is PuTTY. The USR 3510 cellular gateway will start with these factory default settings. I'll write down the IP address for later use. The gateway has been set up with connectivity to a cellular network. For details of how to set up cellular connectivity, watch these videos on the USR website or at the US Robotics channel on YouTube. In this demonstration, my target equipment is a Cisco ASA 5505. It provides a command line interface through a console port, and these are the serial parameters at factory default. I'll write down these settings for later use. The console port is a DTE, presented on an RJ45 connector. When configuring your target equipment, you'll have to know its serial parameters, the connector type, whether it's a DTE or DCE, and how to access its command line interface, if provided. The cellular service for this gateway is a 5 megabyte data plan, and it has a static IP address. And my cellular service provider has set up an L2TP VPN tunnel between my terminal and their network to allow mobile terminated connections. The demonstration begins by choosing the serial cabling that will connect the gateway to the target equipment so they can transfer serial data. The gateway's serial port is a DCE, presented on a DB9 female connector. The Cisco console port is a DTE, presented on an RJ45 connector. So the correct cabling is a standard Ethernet cable and a DB9 female to RJ45 adapter and a DB9 male-to-male gender changer. I'll gather these items for later use. Now I'll configure the cellular gateway for a serial port to TCP and ICMP. Before proceeding, be sure that the cellular gateway has been configured to prevent unintended excessive data usage. Details about excessive data usage can be found at this USR webpage. The cellular gateway's DHCP server is enabled, and since Windows uses DHCP by default, I can just connect a short Ethernet cable from the terminal to the gateway and launch my web browser. I'll enter the cellular gateway's IP address into my web browser. The gateway prompts for a login, so I'll enter the default credentials. This is the embedded user interface of the cellular gateway. First, I'll configure serial port to TCP, so I select the plugin tab and choose serial and GPS settings. To enable serial port to TCP, I'll change the enable setting to yes. Now I'll configure the serial settings to match the Cisco console port's serial settings. In this case, the default settings already match. This demonstration will be showing the cellular gateway receiving a mobile terminated connection, so the TCP server must be set to local. The default setting is already set to local. If I were demonstrating a mobile-originated connection, I would set the TCP server to remote, and a text box would appear for entering the IP address of the host. Since I'll be using PuTTY to manually connect, I can choose any port number, so I'll keep the port number set to 8889. If the host was an application that's using a different port number, I would enter that port number here. To finish enabling serial port to TCP, including any changes made, click the Save button. Next, I'll enable ICMP, so the gateway will respond to a ping test. I'll select the Interfaces drop-down list and choose 3G connection, and scroll to the General settings. To enable ICMP, I'll change the Allow ICMP setting to Yes, and click the Save Changes button. The gateway configuration is now complete, so I'll close the browser and disconnect the Ethernet cable from the terminal and gateway. Now I'll verify cellular connectivity to the gateway. I'll connect the terminal to my local area network, which gives me access to the internet. The gateway has been previously set up with connectivity to a cellular network, and a VPN tunnel has been set up. So now I'll use a ping command to test connectivity to the gateway. At a command prompt, I'll enter the ping command with the IP address of the cellular gateway. This response confirms that I have cellular connectivity to the gateway. If this test had failed, I would check that the gateway has a cellular connection, check that I used the static IP address that was provisioned for this gateway, and check that the VPN was correctly installed and enabled. Finally, I can test connectivity to the target equipment. I'll connect the gateway to the target equipment using the cables and adapters I chose in Step 1. Now I'll launch PuTTY. I'll select a raw connection and enter the cellular gateway's IP address and destination port number. And open. I have set PuTTY to force local echo off and to force line editing off, so I'll just enter a question mark to prompt the target equipment for a response. This is the response of the Cisco console port sent to me over the cellular connection. This confirms that I now have end-to-end connectivity with the target equipment. In this video, I've explained how to set up and test a cellular M2M system to make mobile-terminated or mobile-originated connections with remote serial equipment. The mobile-terminated setup requires a cellular gateway that's provisioned with a static IP address and a VPN tunnel connecting the host to a private cellular network. The gateway's serial port must be connected to the target equipment's serial port with proper cables and adapters, and a cellular gateway must be configured for serial port to TCP and ICMP. The mobile-originated setup requires a local host that's provisioned with a static IP address and a VPN tunnel connecting the gateway to the local area network. The gateway's serial port must be connected to the target equipment's serial port with proper cables and adapters, and the cellular gateway must be configured for serial port to TCP. For more details about the cellular gateway, see the USR 3510 user guide, which can be downloaded from this USR support page. I hope this video was helpful for understanding how to set up an M2M system to make cellular connections to or from remote serial equipment. Thank you for watching, and thank you for choosing USR.